Today we're going to be solving quadratic equations by completing the square. We started this the other day. Today's problems are going to get a little bit more complicated. So let's just review the steps that we had used. We were working with equations in standard form, which was ax squared plus bx plus c equals 0. Our step one was to get all the variable terms to one side of the equation and the constant term on the other. Then we needed to check to see if a was 1. If not, we were dividing each term by a. Then we found half of b, squared it, and then added that to both sides of the equation. Step 4 was to factor the side with the variables, and we should always come up with a perfect square. In fact, we can factor it just by using this b over 2 that we got from step 3. So it'll be x plus b over 2 squared, or x minus b over 2 squared, depending on the sign of b at the beginning of the problem. Then we will solve by the square root method, which means we're going to be taking the square root of both sides. Remember to use plus minus, and then solve for x. So here's our first yucky problem. 4x squared plus 4x minus 11 equals 0. We're going to have the same first step we did on the other problems that we've done so far. So we're going to get all of the x terms on one side and the constant term on the other. So we'll add 11 to both sides. So we get 4x squared plus 4x equals 11. And we check to see if a is 1. A is the leading coefficient and it is 4. So we're going to need to divide each term by 4. That leaves us with x squared plus x. I'm going to leave a space, and that equals 11 over 4. The next step was to find b over 2. In this problem, b is 1. So I'm going to have positive 1 divided by 2, which is 1/2. And then I'm going to square 1/2. 1/2 squared is 1/2 times 1/2, which is 1/4. This is the number we're going to be adding to both sides. So I will add 1/4, add 1/4, and then I'm going to be factoring the left side, the side with the variables. When I factor that left side, I'm going to use this value right here to factor it. So I use 1/2 to factor. Since it's a positive 1/2, this side is going to factor into x plus 1/2 parentheses squared equals, and then 11/4 plus 1/4 is 12/4. 12/4 is equivalent to 3. So I'll have x plus 1/2 squared equals 3. Next step is to take the square root of both sides. And that leaves me x plus 1/2 on the left side equals plus or minus the square root of 3 on the right side. I still need to solve for x, so I will subtract 1/2, subtract 1/2. That negative 1/2 goes in front of the plus or minus symbol, so it's going to be x equals negative 1/2 plus or minus the square root of 3. Now that square root of 3 is really a fraction with a denominator of 1. And what we're going to want to do is combine these two terms into one single fraction. So I will need to get a common denominator. Since the square root of 3 is over 1, I will multiply by 2 in the numerator and by 2 in the denominator. So now I have x equals negative 1/2 plus or minus 2 square roots of 3 over 2. And then as the final step, what we're going to do is we're going to write these two terms, since they have the same denominator, we're going to write them all over 1. So x is going to equal negative 1 plus or minus 2 square roots of 3 all over 2. Okay, let's look at another one that you might not think is pretty. How about 3x squared plus 4x plus 4 equals 3? We want to start out by getting all the variable terms on one side and the constant terms on the other. So I will want to subtract 4 from both sides. And that's going to give me 3x squared plus 4x equals -1. Then I want to check to see if the coefficient in front of the x squared is a 1, which it is not. So I need to divide each term by 3. So now I have x squared plus 4/3 x, leave a space, equals -1/3. On this one, b divided by 2 gets a little bit complicated. I'm not going to write 4/3 over 2. I'm going to think of it as a positive 4/3 divided by 2. And then I'm thinking about 4/3 like I would 4 of anything else. So if I had 4 apples divided by 2, I would have 2 apples. If I had 4,000 divided by 2, I would have 2,000. So when I have 4/3 divided by 2, I'm going to have 2/3, and that is going to be a positive value. I have to square that 2/3, so 2/3 squared, which really means 2/3 times 2/3, which gives me 4/9. Now 4/9 is the number that I will add to both sides. And positive 2/3 is the number I will use to factor. So I'm going to add 4/9 to both sides. And then I'm going to factor the left side. Notice that I already have this positive 2/3 that I'm using to factor, so it just factors into x plus 2/3 quantity squared. And it's going to equal, well, I have to add -1/3 plus 4/9. So that's going to be -3/9 plus 4/9, which is going to be positive 1/9. So this is going to equal 1/9. At this point, I can go ahead and take the square root of both sides. So square root. The square root of x plus 2/3 squared is just x plus 2/3. And the square root of 1/9 will be plus or minus. And remember, I can think of this as the square root of 1 over the square root of 9. So it'd be plus or minus 1/3. And then to solve for x, I'll need to subtract 2/3 from both sides. Remember that minus 2/3 goes in front of the plus or minus symbol. So I have x equals -2/3 plus or minus 1/3. Now these are like terms, so I'm going to go ahead and do the two problems. X equals -2/3 plus 1/3, which would be x equals -1/3, or x equals -2/3 minus 1/3, which is -3/3 or -1. There are my two values for x. X can equal -1/3 or x can equal -1. Here's our next example. We're going to do 2 more and then call it good. X squared plus 24 equals 9x. Now this is not in the format that we'd like to have it in. What we want is all of our variable terms on one side and our constant term on the other. And since I always like to start with my x squared being positive, I'm going to go ahead and subtract the 9x to be over with the x squared. And then I'll have all my variables on the left side. And then I'm going to subtract the 24 to the other side so that I have my constant term on that side. So I'm going to have x squared minus 9x equals negative 24. Next up, I want to check to see, is my leading coefficient 1, which it is. So I'm going to go ahead with b divided by 2. So negative 9 divided by 2 is actually just negative 9 halves. And then I need to square that, so negative 9 halves squared would be negative 9 halves times negative 9 halves. Negative 9 times negative 9 is positive 81. 2 times 2 is 4, so that is 81 fourths. Remember, the 81 fourths is what I'm adding to both sides. And the negative 9 halves is what I use to factor. So I'm going to start with x squared minus 9x, leave a gap, equals negative 24. And I need to add 81 fourths to both sides. So plus 81 fourths plus 81 fourths. Next step is to factor the left side. That factors very quickly since I have the negative 9 halves over here. So it's going to factor into x minus 9 halves squared equals. Then I need common denominator to be able to combine the negative 24 and 81 fourths. So I have negative 24 over 1, so times 4 would equal negative 96 fourths plus the 81 fourths that I had from before is going to give me negative 15 fourths. At this point, I can go ahead and take the square root of both sides. So the square root of this side, square root of this side. On the left side, the square root of x minus 9 halves squared is just x minus 9 halves. The right side is a little bit more complicated. Remember, I can think of this as the square root of negative 15 over the square root of 4. Now the square root of 4 is nice, we can handle that, so it's going to be over 2. But the square root of negative 15, we've got negative 15. The negative comes out, turns into an I. 15 breaks into 3 times 5. Both of those are stuck in. So I'm going to have plus or minus I square roots of 15 all over 2. I still have to solve for x, so I will add 9 halves to both sides. Remember that the 9 halves goes in front of the plus or minus symbol. So right now we have x equals 9 halves plus or minus I square roots of 15 all over 2. Now just like we did in the last problem, we're going to want to combine this, since it has a common denominator, into a single fraction. So that will actually give us x equals 9 plus or minus I square roots of 15 all over 2. And that's how we'll leave our answer. Okay, we are on to our last example for today. Three x squared minus 9x plus 1 equals 0. We'll start out the way that we've been starting out, and that is by making sure that all of our x terms are on one side and all of our constant terms are on the other. So we're going to want to subtract 1 from both sides. And that gives us 3x squared minus 9x equals negative 1. Then we need to make sure that our leading coefficient is 1. Right now, the leading coefficient is 3, because I've got that 3 in front of the x squared. So I'm going to need to divide each term by 3. I know that's going to make fractions, but that's okay, we'll deal with it. So the 3x squared divided by 3 leaves us with x squared, and then minus 3x, and leaving a gap, and that equals negative 1/3. Next step is to find half of b. Well, this time b is negative 3, so when we do negative 3 divided by 2, that gives us negative 3 halves. Okay, this is the number we're going to use to factor. Then we're going to take negative 3 halves squared. Negative 3 halves squared is negative 3 over 2 times negative 3 over 2, which will be positive 9/4. This is the number we add to both sides. So I'm going to add 9/4 to the left side, add 9/4 to the right side. My next step is going to be to factor this left side, which I'm using negative 3 halves to do. So that will be x minus 3 halves, parentheses, squared, equals, and I need to do negative 1/3 plus 9/4. In order to do that, I'm going to need like terms. So I'll have negative 1/3 times 4 will be negative 4/12, and then 9/4 times 3 will be 27/12. So when I combine my negative 4/12 plus my 27/12, that is going to give me positive 23/12. And now I'm ready to take the square root of both sides. So square root, which leaves me with an easy x minus 3 halves on the left side. And on the right side, not so much. Remember, I'm thinking about this as the square root of 23 over the square root of 12. Now 23 is a prime number, so nothing's going to simplify out of that. So I'll just have plus or minus square root of 23 in the numerator. Let's see how 12 simplifies. 12 would be, 2 times 6. And the 2 doesn't break down, but the 6 breaks into 2 times 3. So I have a pair of 2's that comes out and turns into a 2. And then I have this 3 that stays in the radical. So I'm going to have 2 outside the radical and 3 inside. So this will be 2 square roots of 3. Now we've seen these kinds of problems before, where we have a radical in the denominator. And in the past, we've always had to rationalize the denominator. This problem's not any different. We're going to need to rationalize this denominator. And we do that by multiplying the numerator and denominator both by the square root of 3. So I take times the square root of 3 times the square root of 3. I know I'm leaving this x minus 2/3 alone right now. That's okay, I'll deal with it in a minute. So now I have x minus 3 halves equals, that's going to be plus or minus, the square root of 23 times the square root of 3 is the square root of 69 over 2 times the square root of 3 times the square root of 3 will be 2 times regular 3, or 6. Now I'm ready to add the 3 halves to both sides. So plus 3 halves, and that goes in front of the plus or minus, plus 3 halves. So x equals 3 halves plus or minus the square root of 69 over 6, not in the radical. And then I'm going to want to do that thing where I get the common denominator and write it all over 6. So I'm going to want to change it to where it's x equals something, 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 all over 6. So I need to change the 3 halves into sixth by doing times 3 times 3. So that's going to be 9 9/6 plus or minus the square root of 69 all over 6. And that is how we will leave our answer.